Imagine sending a text message and having to wait 22 hours just to know if it was delivered. Now imagine that message isn't a text. It's a precise technical command, sent to a spacecraft the size of a small car, built with 1970s technology, traveling at over 60,000 kilometers per hour, somewhere beyond our solar system. This isn't science fiction. This is exactly what NASA engineers did in 2024. And it worked. Today we're going to break down how a team of scientists repaired Voyager 1 from 24 billion kilometers away, using an emergency workaround that hadn't been tested in decades. Buckle up, because this story is one of the most remarkable feats in the history of human spaceflight. Voyager 1 launched on September 5, 1977. Before the internet, before cell phones, before personal computers. It was designed for a 5-year mission. Fly past Jupiter and Saturn, take some pictures, send back data, then shut down. But nobody switched it off. And here we are, almost 50 years later, and this little spacecraft, powered by a plutonium nuclear battery slowly dying of old age, is still out there. Still talking to us. To understand why the 2024 repair was so extraordinary, you need to understand just how far away Voyager 1 really is. It has crossed what scientists call the heliopause, the boundary where the sun's influence ends and true interstellar space begins. No human-made object has ever traveled further. The signal Voyager sends back travels at the speed of light, and it still takes over 22 hours to reach Earth, one way. That means if engineers send a command, they wait nearly 2 days to know if it worked. In late 2023, something went wrong. Voyager 1 was still alive. Its signal was still reaching Earth. But the science and engineering data it was transmitting had become pure gibberish. Completely unreadable. The spacecraft was essentially talking, but no one could understand a word it was saying. For months, the team at NASA's Jet Propulsion Laboratory worked the problem. They knew the spacecraft wasn't dead, the signal strength was normal. The issue was in the data itself. They suspected one of Voyager's 3 onboard computers, called the Flight Data System, or FDS. This computer is responsible for packaging all the data before sending it back to Earth. Something inside it had broken down. Now here's what makes this uniquely difficult. The engineers who built Voyager 1 are mostly retired or no longer with us. The original source code for its computers exists in old paper documents and decades-old digital files. There is no customer support line. There is no software update you can just push remotely. Every single action has to be thought through extremely carefully, because one wrong command could permanently silence humanity's most distant explorer. After weeks of analysis, engineers narrowed it down. A single chip inside the flight data system, responsible for storing a small portion of the FDS memory, had stopped working correctly. That corrupted memory was contaminating the data before it could be transmitted. The chip couldn't be physically replaced. It couldn't be rebooted the traditional way. So the team had to get creative. The solution? Move the broken code. If the corrupted memory chip was causing the problem, they would redistribute the affected software, splitting it up and storing the pieces in different, healthy sections of the FDS memory. Think of it like having a flooded room in a house. You can't fix the flood right now. So instead, you carefully move all the furniture to dry rooms, making sure everything still fits and still works together. But here's the catch. The FDS memory is tiny by modern standards. Every single byte matters. The team had to manually rewrite sections of code that hadn't been touched in decades, making sure the relocated pieces still communicated with each other properly, across different memory locations. It was like performing surgery on a patient you can't see, using tools from 50 years ago, while the operating room is 24 billion kilometers away. On April 20, 2024, engineers sent the first patch. Then they waited. 22 hours for the signal to reach Voyager. 22 hours for the response to come back. Nearly 2 full days of silence. And then, the data came back. Clean, readable. For the first time in months, Voyager 1 was talking to us again, and we could understand every word. Over the following weeks, NASA continued sending additional patches to restore the remaining systems. By June 2024, all 4 of Voyager 1's science instruments were back online, including the tools that measure plasma waves, magnetic fields, and cosmic rays in interstellar space. Data that no other spacecraft can ever collect. Data that is genuinely irreplaceable.